Now, I will explain about the structure of an Android operating system. The Android operating system is an open source system. People say it is Linux, but that is not fully true. Android has kernel which are similar to the Linux, but this is the only few things that similar. Android has the ability to freely modify, invent, and implement our own device drive and feature. As you can see for the image, there are 5 different of an Android operating system. The first layer is Android Application Framework. This application framework is used by the application developer for Android. This part of Android has the very least to do anything with the hardware layer. Android applications are programmed in Java language. After programming an app, the Android SDK tool helps to compile the data, the resource files. The second layer is Binder IPC. Binder IPC is known as Binder Interprocessor Communication. This interface allows a programmer to do an application communicate with other applications. It is not the application that communicates, but it's the processor. The third layer is System Service. A service is a compiled piece of code which runs for a long time in the background of an Android operating system without giving any interface. Any application, may it be user or system, can start a service, but it will keep running in the background even if the application is closed. However, there are 2 types of service. The first is started service and the second is bound service. The next layer is HAL or Hardware Abstraction Layer. This layer helps to insert functionality without having any modified to the system. Every other system has a different design HAL since they are made device specific. Last layer is Linux kernel. Compiling a Linux kernel for an Android operating system is similar to the compiling it for a basic Linux OS. The only difference is the Android version is a bit more advanced than the Linux. Main reason being the Android kernel consists of additional features such as the wake clock, double tap to unlock, and the similar feature embedded into the mobile operating system. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present to you about scheduling in Android. Scheduling in Android, it has normal scheduling. Android is based on Linux and uses the Linux kernel's scheduling mechanism for determining scheduling policies. This is also true for the Java code entries. The Linux time sliced scheduling policy combine static and dynamic priorities. Processes can be given an initial priority from 19 to 20, very low to very high priority. This priority will assure that higher priority processes will get more CPU time when needed. This level are however dynamic low-level priority tasks that do not consume their CPU time will find their dynamic priority increase. This dynamic behavior result an overall better responsive. In terms of dynamic priorities, it is ensure that lower priority processes will always have a lower dynamic priority than processes with real-time priorities. Android uses two different mechanisms when scheduling the Linux kernel to perform process level scheduling. Okay, we go through to the real-time scheduling. The standard Linux kernel provide two real-time scheduling SCHED FIFO and SCHED RR. The main real-time policy in SCHED FIFO is implement a first in first out scheduling algorithm. When a SCHED FIFO task starts running, it's continued to run until it voluntarily yields the processor block or it's preempted by the higher priority real-time task. It has no time slices. All other tasks lower priority will not be scheduled until it's relinquishes the CPU. Two equal priority SCHED FIFO tasks do not preempt each other. SCHD RR is similar to SCHD FIFO, except that such tasks are allotted time slices based on their priority and run until the exhausts their time slice. No real-time task uses the SCHED normal scheduling policy. Old kernel had a policy named SCHED order. The default Android kernel is configured to allow group scheduling of real-time process, and the file system to control this is mounted under DEV-CPUCTL. Android uses two different scheduling classes using Linux C group, BG non-interactive and default foreground. The configuration is that BG non-interactive in low priority and can be maximum utilize 5% of the CPU including all background tasks, and foreground 95%. Foreground means either an activity or service that are started foreground. Its started service are running in BG non-interactive unless they have been elevated to foreground scheduling group using start foreground HMI. Application are always set to foreground. That's all from me. Thank you.
Hi, I'm Farhan. Today I'm going to talk about process synchronization. The synchronizing in Android can be done also by transferring data between Android device and a web server. For example, transferring data to a web server makes a useful backup, and transferring data from the server makes it available to the user even when the device is offline. In some cases, users may find it easier to enter and edit their data in a web interface and then have that data available on their device, or they may want to collect data over time and then upload it to a central storage area. By using adapter framework for Android, it will help in managing and automate data transfers and coordinate synchronization operation across different apps. When you use this framework, you can take advantage of several features that aren't available to data transfer schemes you design yourself. The advantage is plug-in architecture, which allows you to add data transfer code to the system in the form of scalable components. The second one is automated execution, which allows us to automate data transfer based on a variety of criteria, including data changes, elapsed time or time of a day. In addition, the system adds transfers that are unable to run to a queue and runs them when possible. And the third one is automated network checking. Automated network checking is the system only runs our data transfer when the device has network connectivity. But the advantage can also improve battery performance and allows us to centralize all of our apps data transfer tasks in one place so that they all run at the same time. Our data transfer is also scheduled in conjunction with data transfers from other apps. These factors reduce the number of times the system has to switch on the network, which reduces battery usage. And the last one is account management and authentication. If the app requires user credentials or server login, we can optionally integrate account management and authentication into our data transfer.
Now, I will be explain deadlock handling in Android operating system. What is deadlock? Deadlock is a situation which two application programs sharing the same resource are effectively preventing each other from accessing the resource, resulting in both programs ceasing to function. That's why phone get hacked. Debugging deadlock. Deadlock are well known to be difficult to debug, especially when you are dealing with a large amount of concurrent code. Fortunately, on Android, we have some tools that are more than useful to detect where a deadlock is happening. Probably in their life, we will end up dealing with deadlock at least a couple hundreds times. While a deadlock situation might not be that hard to detect, sometimes it can be hard to detect where the deadlock happened. This usually leads to question the where and how do I trace it. So you start writing a new class if you didn't do that already to track resource allocation and hunt the bug. A very time consuming process, especially if we are in rush. Deadlock identification. How to identify it? It's pretty easy. The only thing we need is routed phone. First of all, deploy your application on the Android, run it, wait for the deadlock to happen, and then connect to the device using ADB, which is Android Debug Bridge. Now, let's see the code using ADB.
Android file system and directory structure. Most of people are familiar with the file layout on Windows and easily navigating the Windows file system. Windows use a driver letters for each partition, example C drive, D drive. A physical drive or partition will have at least one partition, but can have more than one. This is true for both Windows and Android. Android file system structure. Android uses the Linux file system structure, which has a simple root. In the root of Android, usually the file is a default, such as boot animation, or default ringtone, default wallpaper. You can view, but you can write this file. And the SD card is internal storage. It is usually your app and data are stored here, such as Facebook, WhatsApp, or any data such music, video, and there's also SD card external. This is additional SD card, which is external storage, such as a SD card. The system partition and directories are protected, and unless your device is rooted, you don't normally have access to this, although some file manager will display them. Physical disk and partition appear under the root as directories and do not have a drive ladder as in Windows. Android doesn't normally come with default file manager, and so you will need to install a file manager app like Astro File Manager, ES File Explorer to locate and manage files and folders. The SD card and EXT or external SD card partition. The SD card partition is the main storage area for user data and files. It also contains app settings and data. The SD card partition exists even though you may not have an external SD card. It is an internal partition. This file and directories contain your picture, films, and downloads, as well as app data settings. You can view this file from your PC by connecting your device to a PC using a USB cables. You can also transfer files between your device and a PC using this method. The ext SD card partition will only be visible if your device supports external storage, usually using a micro SD card slot. External SD card use either the FAT or FAT and FAT32. Most devices support FAT and FAT32, but support for eXFAT is limited. Android File Association. Just as with other operating systems like Windows, Android will use an app to open a particular file type denoted by the extension. For example, if you try to open a PDF file, it will normally use Adobe Reader if installed to open the file. To open file, you will normally need to locate the file using the file manager. Just press them and open it. If the file type doesn't already have an app associated with it, you should be prompted to choose between the available apps. The option to always use that app set it as the default app for the file type. If you set it as the default app, you will not be prompted again unless you remove the association. To remove an association, you need to remove it from the app itself. So, if the PDF file open with Adobe Reader and you want to change it, just go to the setting, add, and select Adobe Reader. Then go to the Launch by Default section and clear default. File downloads. When you download a file using Google Chrome or another browser app, the file is stored in the download directory. You can access the directory content through the shortcut in the app folder if improved. You can also use a file manager to locate it, the folder called download. It is under your primary storage, like SD card. As the summary, Android uses the Linux file and directory structure, which consists of a single root. On drive and partition are displayed as directories in this tree-like structure.
Hey guys, my name is Asra Iman. So let's talk about OS structure. There are many types of OS structure such as monolithic or simple structure, layered approach, microkernel, modular, and hybrid. So let's see how the Android are. So next is process scheduling. Process scheduling are easy to describe, which is we do something or we run something simultaneously. So for example, we do web browsing or we write some note on Microsoft Word while we listen to the music or something like that. We do that simultaneously. So to do so, the CPU must maximize the CPU use to quickly switch to process for make a successful time sharing. So let's move on to the next point, which is process synchronization. Process synchronization has a term that we must know because it is important, which is the critical region. So I think that I should give an analogy to explain this. So consider there is two rooms. The first is for the waiting room and the second is in the critical region. So separation of the two rooms have a door which is can enter by a person one at a time. So in the waiting room there are 3 persons, which is C, D and E. So they will going to the what we call it. So let's say one of the 3 person, maybe C, is going to enter the critical region. So the D and E must wait for C to complete the process. So then it will continue for the D and E. So that's it's not necessary for some process that come to the critical region will complete. So there might some case that maybe C is end the process and must repeat it again. So C must wait for the last queue on the waiting section. So the next is deadlock handling. So first we must know what is deadlock. So deadlock is something that we can't do simultaneously or at the same time. So it's like a thread or process which are blocked or cannot proceed. Got it? So there are 4 conditions for deadlock to occur. So the first is mutual exclusion. So the second is hold and wait, no preemption, and circular ways. So let's see how Android do the deadlock handling. So the last thing is file and directory structure. So files are very common, and we know that file have many attributes such as the type of the file, name, size, while directory, which has 1 level, 2 level or 3 structured directory.